Knowledge you seek, I shall provide. So, guys, so what do we have here? We have an integer equation, and we're supposed to prove that there are no solutions. So, how do we do this? So, what do we have here? We have a 3 and we have a 7. I'm thinking modulus 3, maybe. Okay, so we'll start by just moving things around. So if I just move this to the right hand side and move that over, we have that x to the power of 4 plus x squared minus 7 is equal to 3y squared. And what is 3y squared? 3y squared is very much divisible by 3, equal to 0 modulo 3, that means. So this is supposed to be divisible by 3, this left-hand side. So to see if there are any cases in which this is true, then we'll just try all the cases for all x. No, of course not. For all residue with division 3, or all possible modulus 3 things. Yeah, you get the point. So we have the first one where, okay, if x is divisible by 3, what does that mean? That gives that this thing, we'll call that left side, this thing. This gives, okay, so if x is divisible by 3, then what is x to the power of 4? Well, obviously divisible by 3, x squared also divisible by 3. So what we get left is the left-hand side modulo 3 is equal to minus 7, which in modulo 3 terms is the same as 2. Yes. Okay, so that did not make the cut. That did not work. So we can, like that, that did not work. I can just do this instead. Okay, so we have next case. X is equal to 1 modulo 3. What does that give? That implies, okay, since we're all only counting modulus 3, we can, well, firstly, we would describe x as a something times 3, some integer times 3 plus 1. Okay, now I'm maybe being a bit basic to you, but I think you can bear with me. So if we have this to the power of 4, what does it become? Okay, we have a bunch of factors of 3, and then at the end we have a 1. So that means that the left-hand side in modulo 3 is equal to, well, we get a 1 plus 1 minus 7, which in modulo 3 is equal to, well, obviously minus 5 and then plus 6. Okay, so that's 1. So it's still not divisible by 3. So that doesn't work either. And now for the last case, x modulo 3 is equal to 2. And here, I can just write down the same thing as above. So here we instead have that x is equal to some number times 3 plus 2. So what does this mean? Okay, so we have that It's the same thing here. The only term left from when we to do this to the power of 4 is, in this case, it was 1 to the power of 4, which is just 1. And here we have 2 to the power of 4. What is 2 to the power of 4? It's 16. So we get 16 plus, and then the same thing here. So 2 to the power of 2, which is 4. And then again, minus 7. And this is, well, okay, first you can just say what it is. It's 13, which is not divisible by 3 because it has the divisor 1, 1. Yes, exactly. So this did not work out either. And frankly, that's all the cases there are. X can either be divisible by 3, be equal to 1 uh, with the modulo 3, or equal to 2 in modulo 3. That's all there is, because then it just, after that, it just goes around. So therefore, we have concluded that this thing is never divisible by 3, which the right-hand side always is, so therefore they never coincide. And thereby we have proven it. So that was me for today. See you some other time. Bye bye.